All right, folks, let's take a look at lesson 7.3.1, studying quadrilaterals on a coordinate grid. This is an extra problem. As I promised at the end of the last video, I was going to do one extra problem where perhaps we would see a special quadrilateral. Okay, so let's go ahead and get started here. Consider the quadrilateral, oh boy, look at that, it's barf, seriously. Who comes up with these names? But it has the coordinates 2, 1 for point B. Let's show that. 2, 1 is point B. And then point A is 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. So that's point A. Point R is 10, 6. Point R. And then last but not least, we have F, which is at 8, 2. Let's go ahead and draw in the segments for that quadrilateral. Boom, there's our quadrilateral barf. Now we're asked what type of quadrilateral is this, and justify your conclusion. In order to justify our conclusion, we're probably going to have to compare side lengths. We're probably going to have to compare slopes, that type of thing, which I showed you in the previous lesson. So I'm going to go ahead and calculate the length and the slope of each side of this quadrilateral. I'm going to go ahead and run through that really quick. Hopefully you can keep up. Okay, so let's go ahead here and start with BA. I'm going to write the coordinates in here next to each of these points because it's easier to reference when you see it on the graph. Remember that slope, let's start here with slope for BA. Remember that slope is delta y over delta x. So that's going to be 5 minus 1, the change in y, over 4 minus 2, the change in x. That gives me 4 over 2, which is just plain old 2. Another way you can do slope is, rather than going through the calculation, I'm okay if you count rise over run. I'm okay if you count delta y over delta x on the graph. But you do need to report it somewhere, so make sure you're writing somewhere what you calculated that slope is, whether that calculation is from a formula or whether that calculation is from counting on a graph. Make sure you document your calculation somewhere. Okay, let's move on to the length of segment BA. Okay, again, the distance formula here was used. It's the square root of x squared plus y squared, and really that is just the Pythagorean theorem rearranged, because we can make a right triangle on the graph and find the length of the hypotenuse with the Pythagorean theorem. All right, now I'm going to rip through the rest of these calculations really fast. Here we go. Okay, folks, so I've got all four sides calculated their slope and their length. Let's just take a quick look here. I'm gonna change the color on a couple objects here just for discussion. I'm gonna take this stuff right here. Let's make that blue. I'm gonna do the same thing down here. And I'm doing that for a very specific reason. If we take a look at the things in red, you'll notice that BA, segment BA, has the same length as the segment across from it, RF. So I'm going to add congruent mark to the picture. You'll also notice, by the way, both of those segments have a length of the square root of 20. Both of them also have a slope of 2. So not only are they congruent, they are also parallel. So I'm going to add parallel marks on those two sides. Now let's turn our attention to the blue segments. So maybe I can even change these to blue. Now those segments match up with the blue calculations that I have. So let's go ahead and take a look at what we have there. We have both the top segment AR and the bottom segment BF. They both have a length of the square root of 37, which is about 6.083 units. So I'm going to add congruent marks there. And they also have a slope of 1/6. They both have the same slope. That means those two segments are parallel. Okay, folks, so let's zoom out here and let's look at a final conclusion we can make here. We're done calculating side lengths and slopes. So time to make a conclusion. We know this. Segment BA is parallel to RF because they both had a slope of 2. We also know that segment AR is parallel to BF because they both had a slope of 1/6. That means BARF, and again, who named that thing? BARF is a quadrilateral with opposite sides that are parallel. That means BARF's a parallelogram. I'd encourage you to go back and look at the quadrilateral org chart because there you'll see that the definition of parallelogram is quite simply a quadrilateral with opposite sides that are parallel. What if this quadrilateral had been a square or had been a rectangle or a rhombus? Well, you have to look to see if side lengths and slopes match the properties of those other special quadrilaterals. For example, a rectangle and a square have 4 right angles, so we would be looking for that relationship of opposite reciprocals between the slopes of adjacent sides. Okay, folks, that's it for this video. I hope you've enjoyed. Please stay tuned for another fun and engaging geometry video shortly.